1. Which of the following is a characteristic of deep neural networks? A. Requires less data for training. B. Can automatically learn hierarchical representations. C. Suitable only for linear models. D. Low computational cost. Two. What is a primary advantage of using LSTM networks over standard RNNs? A. Simpler architecture. B. Ability to remember longer sequences. C. Faster computation. D. Fewer parameters. Three. In convolutional neural networks, what is the purpose of pooling layers? A. To increase the dimensionality of data. B. To reduce computation by downsampling. C. To apply activation functions. D. To add nonlinearity. Four. Which of the following techniques helps prevent overfitting in deep learning models? A. Increasing the learning rate. B. Dropout. C. Using more epochs. D. Removing regularization. Five. Which framework is known for its dynamic computation graph? A. TensorFlow. B. Keras. C. Theano. D. PyTorch. Six. What is the primary purpose of the softmax function? A. To apply activation in hidden layers. B. To calculate probabilities for multi-class classification. C. To normalize input data. D. To perform batch normalization. Seven. Which of the following is not a commonly used deep learning framework? A. TensorFlow. B. scikit-learn. C. PyTorch. D. Keras. Eight. In a long short-term memory or LSTM cell, which gate is responsible for deciding what information to remove from the cell state? A. Forget gate. B. Input gate. C. Output gate. D. Update gate. Nine. What is the role of the vanishing gradient problem in neural networks? A. It helps in faster convergence. B. It prevents the network from learning. C. It accelerates training. D. It improves generalization. 10. Which technique is commonly used to address the vanishing gradient problem? A. Sigmoid activation function. B. Weight initialization. C. ReLU activation function. D. Increasing the learning rate. Transfer learning is commonly used in which of the following tasks? A. Small datasets with little labeled data. B. Tasks requiring large computational resources. C. Low-dimensional data tasks. D. Traditional machine learning problems. Which of the following is true about residual networks or ResNets? A. They use LSTMs to enhance performance. B. They allow easy backpropagation in deeper networks. C. They have no skip connections. D. They can only be applied to image data. Dropout in deep learning is primarily used to A. Improve the speed of computation. B. Increase model complexity. C. Reduce overfitting. D. Increase the number of parameters. Batch normalization is used to A. Prevent overfitting. B. Standardize the inputs to each layer. C. Reduce the number of parameters. D. Increase training time. Which architecture is commonly used for sequence-to-sequence tasks? A. ResNet. B. Convolutional neural network or CNN. C. Recurrent neural network or RNN. D. Transformer. A CNN typically consists of which of the following layers? A. Convolutional, pooling, and fully connected. B. Fully connected, decision tree, and dropout. C. Pooling, KNN, and decision tree. D. Convolutional, PCA, and SVM. What is an epoch in the context of deep learning? A. A complete pass through the entire dataset. B. A batch size parameter. C. The rate of weight update. D. A convolutional filter. Which loss function is typically used for binary classification? A. Mean squared error or MSE. B. Cross-entropy loss. C. Hinge loss. D. Cosine similarity. The process of adjusting the model's weights in deep learning is known as A. Initialization. B. Propagation. C. Optimization. D. Classification. 20. Which of the following best describes backpropagation? A. Initializing weights randomly. B. Forward propagation of input data. C. Calculating gradients and updating weights. D. Normalizing data. 21. Which of the following is an unsupervised deep learning technique? A. LSTM. B. Autoencoder. C. Softmax regression. D. CNN. 22. Which neural network architecture is primarily used for image segmentation tasks? A. LSTM. B. ResNet. C. UNet. D. GAN. 23. The process of using pre-trained networks and modifying them for new tasks is called A. Data augmentation. B. Fine-tuning. C. Feature extraction. D. Preprocessing. 24. What does GAN stand for in deep learning? A. Generalized adversarial network. B. Graph attention network. C. Generative adversarial network. D. Geometric algorithm network. 25. In transformer architecture, what does attention allow the model to do? A. Focus on all tokens equally. B. Attend to specific parts of the input sequence. C. Increase the model depth. D. Reduce model complexity. 26. Which of the following is not typically part of a deep reinforcement learning algorithm? A. Environment. B. Agent. C. Reward function. D. Loss function. 27. In training GANs, the generator and discriminator. A. Are trained sequentially. B. Have identical architectures. C. Compete against each other. D. Share the same weights. 28. Which regularization method involves penalizing large weights in the loss function? A. Dropout. B. L1 regularization. C. L2 regularization. D. Batch normalization. What type of neural network is commonly used for text classification? A. CNN. B. GAN. C. LSTM. D. ResNet. In transfer learning, using layers from a pre-trained model is known as A. Transfer activation. B. Layer matching. C. Fine-tuning. D. Feature extraction. Deep learning. Deep learning is a subset of machine learning that uses neural networks with multiple layers to model complex patterns in data. By training on large datasets, deep learning algorithms can perform tasks like image and speech recognition, natural language processing, and even decision-making. Its layered approach allows it to capture intricate relationships in data, making it powerful for tasks that require high levels of abstraction and accuracy. Here are 5 top beneficial uses of deep learning. 1. Medical image analysis. Assists in diagnosing diseases like cancer, brain disorders, and heart conditions by analyzing X-rays, MRIs, and CT scans. 2. Autonomous vehicles. Powers self-driving cars by enabling real-time detection of road objects, pedestrians, and traffic signals, enhancing safety. 3. Natural language processing or NLP. Drives virtual assistants, chatbots, and language translation, offering accurate speech recognition and personalized interactions. 4. Fraud detection in financial services. Detects unusual patterns and identifies fraudulent activity in transactions to protect against financial crime. 5. Personalized content recommendations. Delivers tailored recommendations on streaming platforms, e-commerce sites, and social media by understanding user preferences and behaviors.